All right, good morning. Today we're going to talk about how to name acids. We're going to write and name acids today. Acids are a special type of covalent compound formed when hydrogen bonds with a nonmetal or a polyatomic nonmetal ion. The first one we're going to talk about are binary acids. You take a look at the prefix binary. You know, like a bicycle, binary means it has two. Okay, so it's going to be made up of only two different types of elements. One of them has to be hydrogen to be an acid. The other one is a nonmetal. That nonmetal is usually going to come from group 17, okay, which are the halogens. Okay. Remember the halogens: fluorine, chlorine, bromine, iodine, etc. Okay? And if it's a binary acid, it's always going to start with the prefix hydro. So that's going to help you to recognize that, hey, we're talking about an acid that's made up of hydrogen and only one other type of element. So we're going to start it with the prefix hydro. Step 2, we're going to add the root of the word of the nonmetal, and then we're going to follow it with two letters, IC, and then we're going to follow it with the word acid. It's a real easy system. So for example, hydro plus the nonmetal root word plus IC in the acid would mean that hydrogen and chlorine, okay, chlorine being the nonmetal, would be called hydrochloric acid. Okay, again, hydrogen and chlorine, two elements. That means it would be binary. We're going to be hydrochloric acid. So let's just do one for practice. Okay, the nonmetal here is fluorine. Okay, it's hydrogen and only fluorine, so this one is going to be called hydrofluoric acid. And the word acid. Okay. The next one is going to be hydrogen and bromine. Okay, so this one is going to be called hydrobromic acid. Okay, so bromine becomes bromic, fluorine becomes fluoric. All right. Next one. This is a tough one just because of the way that it's pronounced, but the rule is still the same since it's hydrogen and only iodine. This is going to be called hydroiodic tough one, acid. Hydroiodic acid. Okay, and that does it for binary acids. Now we're going to move down the page and we're going to take a look at the oxyacids, okay? The ones that have polyatomics. What we call these are called oxyacids for the obvious reason that they're made up of a polyatomic that contains oxygen. All right, so you're going to need your polyatomic sheet on the back of your periodic table. So go ahead and pull it out for this part, and we'll go through these. Again, these are called oxyacids, okay, for the obvious reason. Okay. They have a formula that has hydrogen and a polyatomic that contains oxygen. So the first one, we're going to take the root of the polyatomic ion, we're going to end it with IC, and then we're going to end it with the second word, acid. Notice these do not start with the prefix hydro. Prefix hydro is only for, that's right, binary acids, only binary acids. So this first one right here is H3PO4, okay? PO4, if you remember, is phosphate. Okay. Sorry about that. Let's clean that up. Phosphate. So we're going to change the ending to IC. So it becomes phosphoric acid. Again, there's the suffix IC. For the next one, let's take a look at this one. The only thing we need to worry about is this. Okay, we're going to find CO3 on the polyatomic ion sheet. And you'll find that CO3 is carbonate. Carbonate. So carbonate becomes carbonic, and the word acid. Carbonic acid. Okay? Next one is nitrate, NO3. Nitrate becomes nitric acid. All right? No hydro because these are what? Oxyacids. This one, this is one we commonly use. This is sulfate. Okay, this one has a little extra syllable in here. You may think it may be sulfuric acid, but it's actually going to be sulfuric acid. Okay? And the root of these polyatomics will kind of come with a little bit of time. So don't panic. If you put down sulfuric acid here, that will come with time. These are a lot cleaner and more straightforward, but this is, remember, one of our strong acids that we should know on site anyway. All right, let's move to the next little section down here where we have the polyatomics that end in ite, I-T-E. So if it ends in I-T-E, if you notice, everything's going to be the same. No hydro. We're just going to change the ending of the word, add a different suffix, and the word acid. So we're going to take the root of the word, of the polyatomic, change the ending to O-U-S, followed by the word acid. So for example, this was phosphite, so it becomes phosphorus acid. Okay, this was phosphite, becomes phosphorus acid. Phosphorus acid. All right, this next one, SO3. Okay, we'll do it together. SO3 is called sulfite. Okay. So when we change the name of it, it becomes sulfurous acid. Okay, again, we're adding a little extra syllable. If you called it sulfus acid, you would be fine, but we actually would call it sulfurous acid. Just kind of one of those odd chemistry things. This next one is nitrite. Okay, earlier we did nitrate. This is nitrite. Okay, so this becomes nitrous acid. Okay, good deal? Okay. ClO2 is chlorite. Okay, so it becomes, that's right, chlorous acid. And that's all it is to it. Now when you're going in the other direction, if they give you the name, you're looking for to see if it has the prefix hydro. If it ends in us or ite with no hydro, then we'll just reverse the process. And we'll do a couple of practice problems on the back. Okay?